Okay, let us talk about some vector properties. We already talked about a lot of the properties that we need to use for operating with vectors, but let's go ahead and make a formal characterization of what the properties are. So we already said that a vector has a direction and a magnitude, but when you have multiple vectors, let's say this is F1, force 1, this applies for any type of vector, but here we mostly talk about force vectors. But the vector could be an electric field, could be a magnetic field, but in this course we talk about force vectors mainly. Okay, and let's say you have another force vector that is on the same direction but a different magnitude. So let's say F1 equals 15 and F2 equals negative 12. So evidently F1 plus F2 would be 15 plus minus 12, which this is equal to 3 newtons or pound force, whatever units you have. Okay, we also know that if two vectors or three vectors or many vectors start from the origin, we can combine them using the properties, using the components x and y, or in general, we can combine them using geometry. And that is by moving the forces to form a closed shape. And this shape is called a parallelogram. Okay? Where this is F1 and this is F2. Then the vector or the line touching both points, the origin and the endpoint, this total force, this line is the combination of F1 plus F2. In this case, we couldn't do it because there's no angles between them. They're completely parallel. But in this case, we can combine them and find the total force, F total, by forming the closed shape. And this line is parallel to this line. F2 is parallel to F2, obviously. So you just basically copy and paste until you're able to form the triangle. Okay? Okay, so let's look at, for example, let's look at this concept. We already know that a system of forces can be characterized using the Cartesian coordinate systems. Okay, so they're telling us that a person is pulling 300 newtons. Okay, so he's trying to, let's say, trying to move this structure or whatever, but it's fixed. So sadly, it won't be moved, but it's just trying to apply some force, or just moving this part on top, let's say. There's a friction, but at this point, we only care about this blue vector, this force. All right. What are the horizontal and vertical components? We know how to do this very easily. This is 300. This is 300 newtons, and this is the angle given. So if you don't know the angle, you simply form the triangle. So this is 8 meters and this is 6 meters. So this triangle is formed by a side of 8 meters and a side of 6 meters. So the length of the rope is, let's say, L is equal to square root of 8 meters squared plus 6 meters squared. The square root of 64 plus 36, and this is square root of 100. And the square root of 100 is 10 units of 10 meters, right? Obviously, because 10 squared is equal to 100. Okay, so we have the length of this rope, which is 10. So we know the length and we know the force. Therefore, all we need to do is find the components, but we don't know the angle. We have to find the angle. And since we know the lengths, we can find the angle with the cosine. So 10 times cosine of alpha, right here, they're telling us that find the horizontally component force components. Okay, so the x component is 300 cosine of the angle, and Fy is negative 300. So this is the other thing that I wanted to check. So the coordinate system is right here. This is the x and y. Notice that y is going up. So y is positive going up and negative going y. So let's go ahead and set up the equation for the force first. And then what we need to do basically is put our component fx and fy like so. Fx is just 300 times cosine of alpha, and Fy is negative, because remember there's a direction with the force, negative 300 times sine of alpha, just like the example is showing us. And then what we were going to do next is, since we have the length of the rope, all we need to do is find the angle, and that's the part that is the geometry of the triangle is giving us the angle already. So for that, this is the part with the forces. So all of this is in units of length, and then we're gonna do another part which is in units of this units of forces, units of newtons, and units of length is in units of meters. In this case, because they're giving us meters and newtons, but it could be with an imperial system of units will be feet and pound force, or inches and pound force, etc. But in this case is feet. So let's set up the equation again. So 10 times cosine of alpha equals, so 10 cosine of alpha equals to this horizontal side, 8 meters. 10 times sine of alpha equals 6 meters. So we know how to do this part, right? We only have to use the calculator to do alpha is equal to, well, let's do the whole step. Cosine of alpha equals a divided by 10, 4, 5, and then sine alpha equals 6 divided by 10, which is 3.5. Got it. Okay, so this is 80%, 0.8, and this is 60%, 0.6. Okay, so what we need to do here is compute the angle, which is alpha equals cosine of cosine inverse, because we have to bring the cosine to the opposite side, of 0.8, and that is cosine. So let's do cosine inverse. Use your calculator for this. 3 divided by 5 equals 53.13. 53.13. 53.13, which is cosine alpha equals to that. But this is what I was going to show you. So since here we already have cosine alpha, and here we have cosine alpha, we don't have to, if they're asking for the angle, this is how we find it, which is 53 degrees. Okay, and the other one is sine inverse of 0.6. Sine of the angle. So we're doing cosine right here, and we're doing sine. Okay, so let's check one thing before we move forward. So cosine, I did the computation wrong. It's cosine inverse of 0.8. There you go. It's not 53.13. It is 36. If you follow me with your calculator, you should be getting 36.8 degrees. All right, and this is the same as sine inverse of 3/5, 0.6, which is equal to 36.8, because it's the same angle. That's why I wanted to do double check. And all this, I'm doing all this to show you, or this is just basically to help us remember how to do these computations. Cosine alpha, again, if you have your triangular shape here, this is 8, this is 6, and this is 10. Yeah, and we're trying to find this angle. This angle we can find with a cosine or with a sine, because we have every single side. So you choose. I'm just showing you here that you need to get the same results if you use the cosine or this sine. But in this case, it's asking us to compute the force. And this is just the geometry, okay? This is just the shape of the triangle. And the actual force, it matters what is that direction. And the direction force direction. It matters the positive and negative side. Remember, that is the most important part of the setup of the problem. So 300 newtons, alpha is right here, this is the origin, and then Fy equals negative 300 times sine of 36.8. All right, so either we do this computation again, or just notice that sine alpha is the same as 4 divided by 5. So this is also equal to negative 300 times 4 divided by 5. These two things are the same. And fx equals 300 positive, because it's going to the right hand side. If it's going to the left hand side, it will be negative 300. So 300 positive times cosine of the angle, but I'm just going to do, I have another typo. So this is 4 over 5, and sine is 3 over 5. So just be careful when you transfer your values. Okay, so let's do that. So 300 divided by 5 is 60, and 60 times 4 is 24, so 240 newtons. And 300, first of all, is negative. 300 divided by 5 is 60, and 60 times 3 is 180 newtons. Okay, let's see. Yeah, so basically the force can be, the actual force is 300 newtons in magnitude, or you can also say that the same force is 240 in the x direction minus 180 in the y direction, I and j. Remember, I corresponds to the unit vector going in the x direction, and j corresponds to the unit vector going in the y direction. That's why the negative is the direction which is going, and what 180 is the magnitude of the force. So that's another example of how to compute forces. So basically, from this book, which for the problems for the actual homework, it does matter the edition that we have. But just to introduce the concept, I'm basically going to go over any of the versions that we can find online. So this is the book that we're going to be following, or at least the author.